Day 3, which is the last day of matrices. So today what we're going to work on is we're going to work on first simplifying matrices expressions. So yesterday and the day before we worked on subtraction, addition, multiplication, scalar multiplication. Simplifying matrices expressions, we're going to put things together. So you'll have a matrix plus another matrix minus another matrix. And we're going to have to worry about PEMDAS and those types of things. And then we're going to solve matrix equations. So you're going to get some solving equations work today as well. Within the matrix, this is our last day on matrix. You're going to have a review day tomorrow. And then just again, reminder that you have an assessment over this stuff on Friday. So today we want to be able to solve expressions and solve equations dealing with metrics. So a couple things you have to keep in mind when you're doing these. Okay, so we've got this first problem here. I'll give you a couple seconds to write this down. So we've got multiple things happening within this matrix. Now the key thing when we're dealing with expressions within matrices is we need to make sure that just like if we're taking, say, just if I'm going 3, we're doing one of those TikTok ones where we're doing something like 3 plus, not go plus, let's go 3 times, we're doing something like, we're doing something like 3 times 2 plus 6. Where you have to follow order of operations. You have to follow order of operations with matrices as well. So remember our order of operations. Remember our order of operations. P stands for parentheses. Take care of parentheses first. So you take care of anything that's inside of parentheses. So in this case, the 2 and the 6 is inside parentheses. So then we take care of that parentheses, and then this becomes 3 times 8. So you take care of parentheses first. The E stands for exponents. We don't have any exponents in this one, but anytime you get done with any parentheses, then you deal with any exponents. The next one is M and D. Take care of any multiplication or division from left to right. Okay, so it doesn't matter if it's division first or multiplication first. From left to right, you do whatever comes first. In this case, we've got 3 times 8. 3 times 8 is 24. That's the solution for this one that I did up there. And then you have, please excuse my dear Aunt Sally. Addition and subtraction are the last pieces of it. Now, keeping in mind, and again, addition and subtraction are done from left to right. But keep in mind that if you see a set of parentheses, inside of that parentheses, because parentheses is first, then you have to follow PEMDAS inside of the parentheses first. Okay, so parentheses was first, so I had to do this first. Then I would have to go down this line. There was only addition in here, so there wasn't anything else for me to do. But if there would have been an exponent, I would have had to have done the exponent first. If there was multiplication inside of the parentheses, I would have had to multiplication first. Okay, PEMDAS is something that you've seen since like 6th grade, 5th grade, somewhere right in there. Most missed questions on TikTok. Okay, so if we're doing it with matrices, so we've got 2 matrices, but we've got a scalar multiplication going on with our second matrices. So we have to take care of that scalar multiplication first. So I'm going to leave the first matrices alone. That first matrices is just 3, 6, 3, and negative 6. Now plus, so now I'm going to do the scalar multiplication that we talked about on Monday. Remember when you're doing scalar multiplication, we're just taking that scalar times each of the elements. So 2 times negative 2, negative 4, 2 times negative 1, negative 2. 2 times 0 is 0. 2 times 5 is 10. So I've got a 4 by 1 and a 4 by 1. Remember, you can only add them if they're exactly the same. They're exactly the same, so I just add the elements. 3 plus negative 4. 3 plus negative 4 is negative 1. 6 plus negative 2 is 4. 3 plus 0 is 3. Negative 6 plus 10 is 4. There's my simplified expression. Okay? And again, keeping in mind we have to follow PEMDAS within this when we're doing these. Okay? Questions with the first one? Second one. Again, I'll give you a couple seconds to write this example down, and then we'll do it together. All right, we look what we have. Notice we have parentheses. You can't sit beside each other because you're going to talk. Don't sit beside each other. That's like 2 more times than I had to do that all last semester.
It's this guy.
So we have parentheses sitting here and here. So we have to deal with what's inside the parentheses first. So I'm just going to rewrite the first one. We've got negative 3, negative 4, negative 1, and 3. I've got a minus symbol, so I'm going to put that minus symbol. Now, I've got a subtraction in the 2 matrices that are inside of the parentheses. So first I need to make sure I can do it. I got a 4 by 1 and a 4 by 1, so we're good. Now we have to subtract them. Don't forget to subtract. So we've got 5 minus 1. So the matrices within there, 5 minus 1 is 4. 1 minus negative 1. 1 minus negative 1 is 2. Negative 5 minus negative 5. So negative 5 plus 5 is 0. And negative 6 minus 0 is just negative 6. Okay, so now I have my new matrices created. Now I just subtract again. So negative 3 minus 4 is negative 7. Negative 4 minus 2 is negative 6. Negative 1 minus 0 is negative 1. And 3 minus negative 6, so 3 plus 6 is 9. And again, if you have to get out your calculators to do that, so be it. That's okay. There's nothing wrong with that. Make your lives easier. That's what calculators are for. And make your lives a whole lot easier. Okay? Moral of the story, you have to follow order of operations, and you have to take care of this parentheses. Let's say, I'm not going to do the parentheses. The parentheses aren't going to bother me. If you think about what you would have if you didn't follow order of operations with this one, it's just minus signs. Can't I just whatever? This would be negative 3 minus 5, which is negative 8. Negative 8 minus 1 is negative 9. That's not our answer. Does anybody know what I did wrong? Why is it wrong? Why is it actually negative 7? But if I do negative 3 minus 5 minus 1, with this being inside parentheses, what's wrong? What didn't I do if I did that? If I had say I had negative 6 times 2 minus 4, and I asked you to distribute it. That's that, right? That's negative 12. What's this? Positive 24. This negative needs to be distributed into both. So if you didn't use the parentheses, this actually becomes a plus sign because you have to distribute that negative in. Moral of the story, don't do that. Okay? Make sure you do inside of parentheses first. Okay? Go ahead, simplify that one. And then we'll move on to solving equations. No parentheses in there, no nothing like that. Should be pretty straightforward. We've got a 1 by 2, a 1 by 2, and a 1 by 2. So we're good to go. We've got plus sign, we've got a minus sign, we've got no parentheses, we've got no exponents, we've got no multiplication. Just add from left to right. 3 plus 3 is 6. 6 minus 0 is 6. 0 plus 5 is 5. 5 minus negative 1 is 6. Just be careful with your symbols, okay? Are we okay with simplifying-ish? Okay. So the second part of the day then was to be able to solve. We wanted to be able to solve equations involving matrices. So if we look at this one, the x represents a matrice. So I want to figure out negative 4 times what matrix is going to give me negative 16, negative 24, 24, and negative 40. So there's two ways to do this. Some of you can look at this and use logic. Okay, I have to take negative 4 times something, and it has to be this first element. Whatever I multiply this by here, when I take negative 4 times that, it has to be negative 16 for that. So negative 4 times what is negative 16? And just 4. So my solution for the first element there is just 4. Okay. If we go to the second element is negative 24. Negative 4 times what is negative 24? 6. Okay, so that's the logical way to do it. Logic works great, but not always. Another way to do these, and we'll do the last two elements that way, is you can write these as equations. Okay, so since I want to find, my next element I want to find is right there, I can write the equation negative 4x equals 24. All I did was took where my variable was and set it equal to the one I was trying to find. I can write an equation for it. So negative 4x equals 24. If you're solving the equation, you divide both sides by negative 4, and you end up with a solution of negative 6. Okay. If I want to find the second row, second column element, negative 40, I set up the equation, and I'll do it in a different color. Negative 4x equals negative 40. So negative 40 is that second row, second column. My answer for this needs to go into the second row, second column. Divide by negative 4, divide by negative 4, 10. So there's our solution to this. So our X matrice is 4, 6, negative 6, and 10. And there's two ways to do it, especially if it's just scalar multiplication. Scalar multiplication isn't that bad. Most of you can do that math within your head, and there's no problem with that. Problem with some of the logic ones and why you would want to do equations is if they're multiple step ones. If it's just singular step, logic can usually take care of it. When it's multiple steps, then logic kind of gets a little bit difficult, and it's easier to set up the equation. So if we have this matrices, and we want to solve and figure out what our Y matrice is, I've got multiple steps going on to this. Okay? I've got 3 being taken times my matrices that I don't know. Order of operations then says I have to subtract the matrices 2, 0 from that to get negative 17, negative 18. logic kind of can go out the window. Now, could some of you figure this out still logically? Sure, you could. It's easier to set up an equation. So if I want to find the first element, so if I want to know what the first element is of my matrices, I'm going to look at the first elements of my known matrices, and I'm going to set up an equation. I'm going to take the negative 17. I'm going to set it equal to 3y minus my first element, 2. So I've got this equation. And this equation is only going to give me the first element of that. So we solve this. We add 2 to both sides. You can solve equations. Negative 17 plus 2 is negative 15. We're left with 3y. Divide both sides by 3. You get as a solution then negative 5. That's my y matrices first element. Sorry, it slid down. To find the second element in our new matrices, I'm going to take the second element, negative 18. It's still going to equal 3y, but now it's going to be minus 0. So I took the second elements and just wrote them as an equation, just as I kind of read it. Add 0 to both sides, which does nothing. Divide by 3. That gives me negative 6 as my second element, which would be R1C2. And there's my new matrices for y. So if I took 3 times that matrices minus the matrices 2, 0, I'm going to get negative 17, negative 18. If it's multi-step, this probably needs to be the way that you do it. Okay. Again, are there other ways to do it? Sure. There are other ways to do it, but we found that writing the equation seems to be the easiest for students because you've solved plenty of equations in your life. All right, work with the person beside you. See if you can find the C matrix. Be careful with that negative symbol in there. Be careful with the minus C. That's going to cause a few issues maybe. See if you can find the matrix C by setting up the equations. And just for reference, I'll go ahead and set the first one up. So there's what my first equation would look like. The first element from each of them, R1, C1, negative 7, negative 11, minus C. Solve that for C. Give me about a minute and a half, minute and 3/4. You have about 30 or so more seconds. All right, so the first one. To solve the equation, add 11. So that gives me 4 equals negative c. So we switch the signs. So negative 4 is equal to our first one. We got negative 4. My second equation, I go to the second element. So R1C2. So negative 13 equals negative 6 minus c. Add 6. Negative 7 equals negative c. So 7 is equal to c. So far, so good. Next one. Second row, first column. That's 3 equals negative 6 minus c. So 9 equals negative c, so negative 9. And then the last one, R2C2, is negative 3 equals negative 7 minus c. Add 7 to both sides, that's 4. So negative 4 equals c. So there are all of our elements. We did them right in order. I would highly suggest that when you do this, do it exactly how I did. Once you found one, don't just go to the next one. Put it in there. Put it in with your new matrix. Okay? Now you can always check it. Negative 11 minus negative 4 is negative 7. Negative 6 minus 7 is negative 13. So you can check to make sure it works. Any questions with solving equations or doing expressions? Are we okay? All right, that is the end of Unit 10. There's no more to it. Tomorrow is going to be a review day.